A little higher.
Okay, 1, 2, 3, go.
Oh boy. Well, it's more oscillatory than I expected.
Damping.
Whoa, look at that overly aggressive turn. Okay, I'm going to turn.
Yeah, so you had really low damping in that mode, but it did damp.
Eventually. Well, it made for a more interesting video then, didn't it?
I'm waiting for the mid-air collision here.
Yeah, please don't hit me.
I think they're going to hit each other. Well, yeah, that's good. The difference in tip speed is going to excite the.
So you still got our little list of things to try?
I pulled it out.
This is not as stable as I'd hoped for, but it's not, you know.
Okay, so your first one was steady state full aileron turns against auto level. And I think you're already doing that, aren't you?
No. But let me work into it here. Okay, starting steady state full left, going gradually increasing the ailerons, gradually increasing the ailerons, going up on throttle to keep. Also holding almost full up elevator to do it.
Okay.
Oh, I backed off on the aileron accidentally, instinctively.
Okay, I'm thinking let's call that enough for the moment.
Okay, coming back to level.
Now, you still got all the auto level on?
Yes, full auto level.
And if you go to the other P, that turns it off?
Yes,
Is that proportional?
yes.
I would try backing off a little bit and see what happens.
Okay, backing off auto level now.
Be ready to shove it back on if you have to.
Okay, I'm at maybe half auto level right now.
Okay.
Whoa. The tip started to come up. That usually indicates a slip is developing. So it's not self-coordinating the turns. I'm having to do that somewhat manually.
Yeah, I'm not too surprised about that.
All right, so we need full auto level for now anyway. So what's one of the other ones we can try?
Drive a hard slip with full rudder and opposite aileron.
Oh, that's dangerous.
That's very dangerous.
I can see where that's going to...
You can't turn off one motor.
No.
You can try gliding.
Okay.
Don't go all the way down.
Okay, reducing throttle, keeping the elevator constant, down to below half throttle now.
Yeah, don't go to full cutoff.
Yeah, because that'll lose my yaw stability.
Right.
It seems to naturally want to turn left for some reason, but that's okay because I like turning left.
Okay. Now that's looking a little bit better damped, actually.
Well, I'm almost at full idle. It's hard to tell by feel.
Right.
Going back up on throttle just to keep the airspeed up.
Yeah.
Yeah, I wonder if like the gain is too high for the outboard panels in your.
That may be.
That could well be. Yeah.
Okay, going back up to like 2/3 throttle.
Okay.
All right. There's the stall one, which is a little dangerous, but
right.
the reason we're here is to learn and
yeah, I'm tempted to say just, don't push it more on this flight.
Well, yeah, but every landing is a risk, so let's get what we can out of it.
Okay, so the only other things that you can do here.
Oh, I can do the full left pulse, or the full aileron pulse.
You can do an aileron pulse.
Okay, so aileron pulse now. Aileron pulse to the right. I kind of expected that.
Do that again?
I will.
Yeah, but just do it so the pieces fall over the field.
Understood.
And I'll need to land pretty soon. How much longer do you have?
Oh, I have time.
Okay, so I can swap batteries and then capture it.
Well, maybe.
I'll be there. for landing.
Okay, full aileron pulse to the left now. Let's do that again where I can see it from the trailing edge now. Yeah, that kind of S-curve thing was kind of expected.
Okay, so you're at what throttle now?
I'm at 2/3 throttle maybe.
Okay, why don't you try the same thing at about 1/3 throttle?
Okay. Let me set it up though.
Yeah. Set it up where we can see it.
Okay, coming around the corner at 1/3 throttle. Actually, that's more like half. Okay, leveling out. Aileron pulse to the right. Yeah, more damped.
Much more.
Pulse to the right, more damped.
Okay, that was a worthwhile experiment.
Okay, so the other thing we haven't done is tried full auto level, full up elevator, reducing throttle till it stalls. That's dangerous, but
Okay.
we got to learn somehow, right?
Right.
Okay, but we don't have our in-air video. Well, we've got our ground video. I think we should keep moving because we'll run out of battery. I don't know how quick Tim can get back up.
He's doing a pit stop.
Yeah, he ran back. He's putting a battery in.
Alright.
Okay.
These batteries will last kind of a long time on this thing.
Yeah, but
It's
you
relative-
don't want to lose one.
No, no. Although, well, we do eventually, but not now.
Right.
So it does seem to be happier at lower throttle settings.
Okay,
That's-
Tim is back up and starting to chase.
So maybe that'll actually help us.
Sorry, that's not Tim.
You know what I could do is an elevator pulse too.
Okay.
It's kind of a non-event.
Yeah.
That was full up elevator. There's full down elevator. Also mostly a non-event.
Tim's here.
Okay,
Where you guys at?
straight out in front of you.
Turn to your right a little bit.
Let me know when you're on station. Okay, getting ready to do an aileron pulse.
That looks so weird from this perspective.
Okay, now an aileron pulse at lower throttle. More damped. Okay, now I just got to make the turn.
I'm trying not to get so close so that it keeps the whole thing
Yeah.
in.
Yeah, and it's safer that way. Okay, getting ready to do the low throttle. Well, let's start feeding up elevator and reducing throttle. This could get ugly here, folks. Feeding an up elevator. Feeding an up elevator, full low throttle. Whoops, I said I wasn't going to do that, which is why I lost yaw control because I was at full idle.
Yeah.
I forgot about that.
Okay,
But nothing happened.
nothing weird there.
Nothing bad happened at all.
Okay, wind up turn at high power and high bank angle against partial auto level.
Well, I think we've already gone as far as we can, even against full auto level, because at high power,
Right.
it starts to get ugly.
Now let's see, have you been at full auto level recently or are you still at half?
I'll tell you what, I just took off a portion of the auto level. I'm starting to wind up the turn. Going up to more and more ailerons, feeding in rudder as well. I'm at full rudder now and feeding in ailerons to go with.
Whoa!
That's doing much better.
Yeah, it's starting to lose it on the inside tip. Okay,
Right,
that's
yeah.
as far as I can go with
You
that.
had that inside tip on with stops.
I know, I know.
I have some airflow to hold it up.
So that, yeah, exactly.
Now, so what auto level was that at?
That was at maybe 50%. It's hard to tell by feel. You could look at the switch in the back, but
Let me. Yeah, you're somewhere around 50.
This would be a good time to talk about the smoke in the air.
okay, so what else is there to do? Anything else on the list?
There's nothing else here that you can do without changing program.
Okay, so Tim, I'm going to do an elevator pulse. I don't think you've seen one of those.
Now, the only other thing would be completely go off on the auto level.
Okay. All right, let's try that. Let's do that. I'm going to turn around so I'm not headed towards the trees. I think it wants to turn left when I do that. So going off on auto level now. That's full auto level off.
Okay, go back on.
Going back on. It's not a great idea, but it doesn't immediately fall out of the sky.
Right.
Let's do a full idle for, since we now know that it'll do it. This is with auto level, but at low throttle. And then we're gonna land because I don't know how much battery we got left.
Okay, you have a slight wind from your right. Very
I hear
slight.
you.
It doesn't matter which way you land.
Okay. So going to full idle now. Full idle, that is full idle right there, full idle. And you see it wants to go into a left-hand turn,
Okay.
but no harm coming up on the power now and turning around, setting up a landing approach. It doesn't feel like I have as much power as I did before. So now is a good time to start landing. I realize I don't want to hit those trees over there.
Yeah.
I think I can turn tight enough to not
You
be,
can totally turn tight enough. The wind has shifted. It's now a little bit behind us.
right?
Not enough to matter.
Well, part of the problem is I lose some yaw authority as I go to lower and lower throttle settings.
Right.
I'm on this side of the trees, I think.
I think you are too.
Yep, you are.
So yeah, you're good.
I'm good now. Coming up on throttle. Leveling. Yeah, that turned tighter than I expected, actually.
Okay. Just
Whoa. Full up elevator. What we really need is airspeed adjustable gains. Now,
you put it this way. You always need airspeed adjustable gains.
okay, let's just keep gentle tension and walk it back.
You want to take it all the way back up to the.
Good morning, everybody. I'm Randy St.Clair, and we're out here at Baylands Park with another my inventions, you might call it. Today's activity was with the Flex Wing, which is a 9 airplane, if you want to call it that. What it is there's these nice, simple little airplanes, and there's 9 of them, of course.
Oh, well, it's Adam's plane.
And they're attached together wingtip to wingtip to make one very big plane. Now each one of them is right about 2 feet in span, so the total is 18 feet. So I just wanted to tell you a little bit about the planes, how they work, how they fit together, and so on. So let's start with, let's see, where's the number 0 plane is right here. So I numbered them, and the number 0 plane is the one that goes in the middle. And then there's the L1 that goes just to the left, and R1 goes to the right, and L2, and L3, and L4, and L5. Well, actually, L4 is the last one in this case. But at any rate, you'll notice this plane has right here, it has a receiver, and it has a flight controller. And it also has these wires that run out to the wingtips, and that's so it can plug into the plane on either side of it. So in this particular case, we've got a group of 3 planes that are all being driven, if you will, by this one common receiver. They all each individually have their own separate flight controllers. Like, for example, this is the R1 plane, so it goes just to the right. It plugs in here like this. And then the L1 would be on the other side. And you notice it does not have a receiver. But it does have the flight controller right here. And by the way, the flight controller is a KK2 or a KK2 variant. It's called a KK Mini. And that's just because it's a little bit smaller, because it's a pretty small plane. So anyway, all of these airplanes are receiving the exact same signal information from the transmitter. That is roll, pitch, and yaw, elevator, rudder, throttle, if you will, all receiving the same information. The flight controllers, however, are programmed slightly differently depending on which plane it is in the array. Now, the main difference is just a matter of polarity. Like the ones on the left respond to ailerons in the opposite direction as the ones on the right. Whereas for elevator, they all respond the same. For throttle, they all respond the same, except that they respond oppositely to rudder input, that is rudder stick input. There's no actual physical rudder, by the way. But when you give it like a rudder command, like left rudder, then the plane on the right-hand side is going to speed up so that it can come around the corner, and the plane on the left-hand side, which I don't have one right here, is going to slow down, and so the differential throttle will actually make the plane yaw in the direction as you've commanded. Now, by the way, the flight controller is doing more than just translating the receiver input. It's also providing stability feedback. So it has what's called auto level, and it has auto level in both pitch and also in roll. Now, I should talk about how pitch and roll work on a plane like this, because you may notice it has no ailerons. This is just a piece of foam board here. It does, however, have an elevator. And it also has a coupler right here, and this is a little soft piece of EPP foam. So the coupler fits into this little slot and these screws hold it together. But it's soft enough that the plane can bend at the coupler. It's got a little bit of stiffness, but it can easily bend, you know, 15, 20 degrees, no problem. And it can also twist a little bit, just a few degrees. So each one of these joints can twist in turn. So the way ailerons works, or roll control, if you will, for the whole aircraft, is that if you want to roll to my left or your right, then you need to twist this plane up and you need to twist this plane down. And you can see it becomes kind of like a propeller, and now it's going to roll to the left or my left. So in order to do that, this plane needs to apply up elevator, because it doesn't have ailerons, it only has elevator. So when this plane applies up elevator and this plane applies down elevator, you get this twisting action and the whole array rolls. So it's a lot like elevons, except that the actual movement of the elevator is in the opposite direction. Now the reason for that is because normally with ailerons, when the right aileron goes down, that means the right wing makes more lift. Well, in this case, when the right elevator goes up, it pushes the tail down, brings the nose up so that the right wing can make more lift. So the polarity of input with regard to roll is opposite for ailerons. So let's see. I should talk about, or I already mentioned these couplers are EPP foam. They're a little bit soft. And they just go together here with these two screws. And we've got a couple little light plywood plates here. We've got the EPP foam. And then there's also right in the middle here, there's a little piece of plywood embedded. It doesn't go all the way through. It only goes through just part way through the foam, so the foam is still flexible. But basically it's just distributing the load from the screws. Because there's two screws, you can see the two screw holes here. And of course the two mating screws here. They are at an angle because, and this is actually very important, this is one of the key elements that makes this even work. And what happens is when the plane flexes, this angle, like let's assume that this is the right wingtip. So when it flexes in this direction, because that is at an angle, it automatically bends the plane so that the nose on the wingtip is pointing down. And versus if it bends the other way, now the angle of the plane on the wingtip is pointing up. That is, it's changing the angle of attack. And this is a self-stabilizing mechanical feature. So now if the plane or the entire array gets out of sorts, it gets bent in whatever direction, then this automatic twisting that's caused by the angle here, and this is a 20-degree angle, by the way, in this case, will tend to push the array back to flat. So this doesn't require any electronic stabilization at all for that purpose. And as a matter of fact, we've done some testing in the air where we've completely turned off the electronic auto level stabilization and even turned off the throttle and just let it glide, and it just glides pretty much flat. So this is key. Without this, it would oscillate and flop around and it would not work at all. This is the most important feature that makes the plane work, actually. A little bit more about the radio system. It's very simple. Matter of fact, each plane is about as simple as you could get. We've got a little Velcro pad on the bottom for the battery. And the battery is a, let's see, it's a 1 amp hour 2S or two cell LiPo. Not a very big battery. Little motor, not very big. These little 5-inch props, doesn't have to be 3-blade, that just happens to be what we had. Then we've got a very standard ESC or electronic speed controller, standard hobby hardware, nothing fancy there. A standard analog servo in the back, which is controlling the elevator. Matter of fact, it's a high-tech HS55, inexpensive servo, nothing fancy. As I mentioned earlier, the only thing that's really a little bit fancy about this radio gear is the flight controller, which is, as I said, the KK Mini, and it is running the OpenAero VTOL firmware. Now this is not a VTOL. It doesn't have enough power to launch vertically, and I'm not sure that it would work even if it did. So it's a standard airplane in the sense that it flies on the wing. But we're still able to use this OpenAero VTOL firmware because it has 2 flight modes basically, and we can infinitely vary between those 2 flight modes. So in this case, what we've done is set it up so that in the 1 flight mode, we've got full auto level stabilization in pitch and roll and automatic turn coordination, all this sort of thing. And then in the other flight mode, we turn almost all of that off. The only thing that I left on for stabilization was a little bit of what's called P or proportional feedback, and that's just meant to provide a damping term. So it still has that, but it turns the auto level off. And that was just as a way of experimenting in mid-flight to see if the auto level was really important, and by the way, it is. You need the auto level. I mean, you could fly briefly without it, but it quickly gets a little not very nice. So the auto level is certainly a good thing, and this is what provides it. And that's why each one of these modules has the flight controller, has the auto level, has the stability feedback, and so on. Take it back to where we started. We'll have to think about what